You never know when it actually happened.
It happened.
Yay!
Hi, everyone. Thanks for joining us today again. We're back with another episode of Deep Random Talks. And today we are going to share our deep random thoughts on UX and machine learning. I have my awesome co-host Roxana with me today, and I'm going to ask her to get us started.
Hi, everyone. Thank you for joining us today. I'm very excited. We have two special guests, Jennifer Fraser and Scott Clues, and I will let them talk a bit about themselves so you get to know them too.
Okay. Thank you, Roxana. So Jennifer Fraser, I'm the VP of Experience at Macadamian, which is a consulting company focusing on healthcare. I've been working in the UX field for, I'll just say, over 20 years and leave it at that. My background is in architecture. And in my role as VP of Experience, I kind of sit at the intersection of user experience, employee experience, and customer experience. And I've spent probably far too much time talking with Roxana and Scott about the intersection of user experience research, and data science. So I'm really looking forward to the conversation today. So Scott, over to you.
All right. I don't think we spent too much time, but
just enough, maybe?
Oh, just enough time. So Jennifer and I worked together for many years, and Roxanne and I for a few. And I've been in the user experience field, and to Jennifer's point, I'll just say for almost 30 years now, between 25 and 30, something like that. Quite a while. Before that, once upon a time, way back in university, I didn't do anything that would qualify me for user experience. In fact, I went through physics and math, which is probably the least qualified thing for user experience you can go through, which I discovered as I learned about user experience. But it's coming in handy now, finally, after 25 years, trying to talk to people in data science and machine learning and other kind of mathy disciplines, which is part of the reason I'm so interested in it. I love to see math and data and science and UX come together. So with that, maybe back to Roxana, because I think you had a story you were going to start us off with, didn't you?
Yeah, so we'll see what everyone thinks of this, but Amir, you're not going to like it. So, our title for the show is Deep Random Talks. And last episode with Serena and Amir, everyone learned about Deep Random Walks, which is an actual algorithm. It's real. It serves a purpose, an alternative to breadth and depth searches. So then Amir asks me, what do we call this? It's like, well, how about, and Scott and I came up with it on the same, independently, Deep Random Thoughts. Amir, I was hoping for something a little less random. So I promised I'll have a good reason for calling it Deep Random Thoughts. So I want to tell you the story, how kind of I had my aha moment of the importance of bridging UX and machine learning. So there's this researcher I really look at or admire, Indy Young, and she's done some work with a large airline company. And as you can imagine, airline companies have all kinds of data, big data sets, and of course they collect things like age, gender, all kinds of demographics, duration of the flight. And the research question was, why do people check in their luggage? And looking at that big, wonderful data set they had, the quantitative analysis revealed a difference by gender. It turned out, I think, that women check their luggage more than men. Not clear why that may be the case, but Indy went ahead and did some qualitative analysis, asking people the true why they check their luggage. What are those reasons? And that's where the random thoughts comes in, because the real reasons have absolutely nothing to do with gender, as far as I could tell. And they weren't captured as data in that data set to start with. So reasons included carrying a precious object, or a doctor who had a medical instrument and wanted to keep it calibrated throughout the duration of the flight, someone having bad experiences before and getting their luggage back covered in this white questionable powder. And my favorite of all was someone carrying a precious beer. So those are pretty random, but the takeaway, I think the most important part was the data set was there, which sometimes that's a problem itself, having a large data set, right? And it revealed a significant pattern, but it provided absolutely no indication towards why, what's the why behind those patterns. So that's how the title came to be.
So that's very interesting. And I think the relevance of what you're bringing up is that, and I guess the relevance to the topic is that probably people who designed the study or designed the systems, environments that these things were happening, didn't really think about all of these different humans involved in the process, and it wasn't as human-centric as it should have been. Is that where you were going with that?
Well, the other thing I think around that is the data is a byproduct of something else that did make sense, right? So there are things they're trying to capture when people are booking. So they'd have lots of data on, how long it takes people to go from one place to another, right? They'd have tons of data on that because they need that data to run the whole airline system, right? And so now that they have that data, why would you think necessarily that would answer a question around luggage? It might turn out that, oh, I'm going to carry it on board if it's a short flight or it's a long flight. But there's really nothing to suspect that it might. The data was a byproduct of some other completely different intent, right? And there's literally almost limitless amounts of data you could gather when it comes to people, preferences or how long or why or all these categories. So even if you have tons of data categories, doesn't mean you're going to find a pattern that's useful to the question you're asking. And I think that's what she knew instinctively. And one of the things, when you do research with people is if you want data about people's behaviors, then you need to ask about how they behave, why they're behaving a certain way, and not assume that the system for some reason has data that's relevant. You might get lucky, might have relevant data, but might not.
Makes me think of two things. For one, that's an ideal place where a UX researcher can come in when you set up that data structure to make sure it's actually aligned and you're capturing the right data to answer the question that you want to answer. And doing that analysis, are the variables that I've captured really truly indicative in any way or sufficient to answer my research question?
That's exactly what I was going to say, Roxana. I think part of the seduction of having the data is just, you've got the data, right? Whereas what Scott and I have talked a lot about is just pausing and figuring out, okay, what question am I actually trying to answer? So what am I actually trying to figure out? Is it something around, kind of the motivation for why somebody would check their bag is a much different question than just the mechanics of whether or not they check their bag and their relating demographic information or duration of flight or all that stuff. But to get at, kind of understanding people's goals and motivations, it just requires a different type of research to get at those underlying desires, motivations. And in this case, really, it was like their emotional attachment to an object that was driving it. And that's something that would just be really, really difficult to figure out from looking at data alone, if it could even be uncovered.
So can I ask a question then? We all know, like from a very pragmatic point of view, we all know that data is expensive. It is hard to collect. And the temptation is very real to reuse data. So find a data set that exists and try to sort of jam it into the new use case that you have. So there are what you're saying is that that's a bad practice. But in reality, especially in industry, you don't always have the opportunity to collect your own data because that will take a lot of time and a lot of money to do. So in a lot of cases, you make a lot of design choices based on existing data. And to some extent, some of these choices are the ones that you cannot necessarily easily change later. So what's we talked about theoretically you have to be careful, but what are some of the practical ways to essentially be careful that the data you're using doesn't have the biases that might hurt you in the future?
I think part of it is just pausing, like honestly, just pausing and just having a really good conversation about what is it I'm actually trying to understand. So what is the question that I'm really trying to answer? And then figuring out what of what you have could help you understand that problem. And part of figuring out the question is stepping back and looking at the system as a whole that you're trying to figure out. Because if you think about the person and whether or not they're checking their bag, that activity is happening within a whole system of, the person, the airline, or they, could be their employer if they're traveling for work, they're going to see a family friend. You just kind of think of the ecosystem as a whole and figuring out, okay, where within here do I need to kind of scrutinize to understand the answer to the question?
Amir, to your point, and to follow up on what Jennifer said, I think the risk with reusing the data without doing this analysis, whether the data can in fact answer the question, is that, for example, in the airline example, the data set revealed the significance by gender. What does that mean for designing or improving the check-in experience? Like, if anything, it pushes towards dangerous waters, towards a stereotype, because I can't think of anything else as a design implication when you get a significance by gender for checking in. And Scott, I'm sure you can speak to some examples where we've came across, solving a solution in isolation with that a small, incomplete system.
Yeah. So so it made me think of something else, actually. So one of the things that when you're reusing data sets so there's two things you said, Amir, that struck me. So one about reuse, another about bias, right? So if you're reusing an existing data set, it's less risky to think of it as the data will give me an answer. The data might give you a pattern, right? So, and usually will, right? If you have enough data, you get a pattern. That's the whole signal to noise problem, right? So, but you're looking for the pattern that matters, which is the signal, right? So but there is kind of sort of in between, right? You might get a partial signal, right? You might get a clue, right? And maybe even the gender is probably not a very good one, but there might be times where you see some sort of pattern that gives you a clue that says, oh, all these people in this geographical area are acting a certain way or something. And then you go interview them and get richer data about their motivations and things like that. And it turns out that there is some characteristic of people in a certain geographical area. And now you've got an answer. So doing the math on data because it's around isn't necessarily a bad thing, because it might give you a clue, but you just have to be thinking, is it signal or is it noise, or is it something, maybe a partial signal, right? It's putting me in the right direction. That's another. The other thing is the idea of doing, Jennifer talked about, I can't remember if you actually used the word, but implicitly, right? That the idea of modeling these things in different ways. So you can model something qualitatively, where you start getting notions like, feelings involved, which are hard to quantify. You can model things quantitatively. And then within those, there are multiple models. I mean, when you do something quantitatively, there's different mathematical models you can use, right? You can pick different frames of reference. You can do Monte Carlo versus something else or whatever. And each time you do these different things, you might get different insights. So now if you think of yourself as, these things aren't the answer, but they're clues, because my models are just some representation of reality. And I've taken all these different models and they're all clues to the reality. Then maybe I can go, aha, right? And that's one of the reasons that, and maybe this is something Jennifer dug up for us at some point. I can't remember. One of the reasons we like this idea of the I don't know if I'll pronounce it right, Cynefin framework, where it talks about complexity and complexity being interdisciplinary. Oh no, I lost Jennifer. I hope other people haven't lost her.
No,
So I was going to
I'm
ask you
still
to talk
here.
about this. You're still there, good. But so you can come at a system from these different models, mathematical, qualitative, etc. So maybe since you're still there, even though you got the camera got disabled on my end, maybe you want to talk a little bit about complexity in the Cynefin framework.
Sure,
So I
of
think
course.
that's
Yeah, Amir, and let me know if I've lost my video feed, but otherwise I'm just going to keep talking. So yeah, the Cynefin framework, it's a sense-making framework. I know we'll share a link out to it with the notes that go with the session. But as Scott was talking about, it goes from things that are kind of simple and kind of complicated, complex, and then chaotic. And when we're talking about things in the complex area, in terms of complex problems, as Scott was saying, you can't just follow a good practice to solve the problem because it's complex. So you need an emergent practice to figure out the solution. And to come up with that emergent practice, you need to have people bringing different perspectives onto the problem. You can't just bring in, a single domain expert that can apply a best practice to it. You need to get together with a bunch of people and have each of them bring their own expertise to then create an emergent solution to the problem. And that's where different models then come into play. And one thing within UX, just a slight side distraction here, with UX, we create models all the time. We just don't talk about them as models. So a lot of our standard artifacts might be a persona or a journey map. Those are models. They're just narrative models. And the reason it's important to think about it as a model, because then you take that model and you take, a model from a data scientist, and it's when you bring those models together that you're really getting at insights, because you're looking at things from those different perspectives that normally wouldn't happen if you're just keeping things kind of siloed in isolation, as which happens in most companies these days. So back to the Cynefin framework, yeah, the idea of complex problems really do need different people bringing different perspectives to figure out how can we work together to figure out the solution to this problem.
So I jump in quickly here to say that, as Jennifer said, we will be sharing a link to a lot of resources where you can read more about all the topics that we're talking about. They will be in the show notes, and you can check them out on YouTube and go through all of the resources with the notes that we wrote about them. So hopefully that will, in addition to this video, those notes will also help you understand and use those resources better. And if you are on the live chat right now, I'm checking the live chat. That's why I'm occasionally looking to the side. Please write comments about your opinions about everything you're talking about, or other resources that that will be helpful that we should add to our list of resources. Do what Andre is doing. He's writing some comments about how they collected data on airlines, in airport, I guess, about how people were onboarding, etc. So definitely very interesting experiences that Andre is sharing. So share your experiences and thoughts as well. So going back to the conversation, one of the very interesting things that I heard from Scott and Jennifer is that data can only give you a partial signal, and then you have to go back and research it further. And I think understanding that partial signal is very important. For understanding that partial signal, it is very important to know the data lineage and assumptions that are made at the point of collection. So a lot of the time we talk about data lineage, but it never had occurred to me until we were having this conversation that a very important thing to document is the assumptions and biases that are happening at the point of collection. Because if anybody wants to use that data in the future, including your future self, you probably need to look at your signal and then those things and be like, okay, does this still make sense, or am I using it for the right purpose, etc. And a very good way to mitigate the risk, as you said, is for different types of mindsets and views to interact with each other. And of course, that means that sometimes data scientists and UX folks end up in the same room. And in my experience, sometimes there's a bit of a spark happening there. What are your observations there?
So one.
Before we jump
Go
into
ahead.
that, because there were kind of two conversations that made me think to a specific example. So for one, the Cynefin framework, I think is really powerful, kind of thinking from simple, complicated, complex, and chaotic. And when we speak about chaotic, it's clear that we need more people, more disciplines to solve those problems. But connecting that with the assumptions and the data, I thought of sometimes there's problems that fall under, apparently, or at first sight, they fall under the simple quadrant. So we were doing a study with nephrology, with nephrologists, and based on tons and tons of data, it looked like the more senior ones were less likely to use a tool in their in the room, in the interaction with the patient. And right away, the initial correlation that became significant, the pattern that emerged was age and less engagement with technology, which it's something that, based on some of our experience, if I think of my grandparents in a village with no color TV, with those cognitive biases in my own experience, it's easy to accept something like a more senior nephrologist may not have the same technology skills. And seeing a significant pattern like that, there's the risk that you will embrace it as true without further validating because it comes closer to home. But what happened in that case, actually, it was that the more senior ones, of course, had a lot more experience, and they were dealing with the most complicated cases, and the face-to-face interaction and the patient needed more care. So it wasn't an option for them to turn away and look at the computer. Some of them were actually great with stats and looking at symptoms and looking at time series and predictions over years and so on. It had nothing to do with their stats or technology skills. But see how close and how risky it is to kind of, it seems simple, it's something that resonates with us, and then we just take it as is.
Roxana, the cuteness of our live stream has dropped. Where did your kid go? And Joseph on the live chat is asking if you have any resources for UX in healthcare specifically. But I think you're talking about a few examples, but we'll make sure to add some resources later, even if we don't have. Scott?
So you're when you get data scientists and UX people together, how do you make that work and so forth? One of the things, I think there's an article Roxana sent out actually around, and it pointed out just how the same words can mean something totally different. So you have to be really careful right from the start to just define. I mean, even the idea of, if you start talking about something complex, right, without mentioning the Cynefin framework, and that's how you're thinking about it, right? If you're more mathematically inclined, you might think of complex problems as how many steps are required to solve the problem, or how much time is required, or a machine learning problem, which is going through all this training and resetting weights and parameters as it goes, versus sending somebody to the moon, where actually all the parameters are set by nature and you have a fixed model that you just use. Right. And you can argue which one of those is more complex, but either way, that's might be how mathematically inclined people are thinking about it. And whereas we're thinking about it in UX more in terms of the fact that you're using multiple models, or you have this convergence of disciplines, or you have these different frames of reference or something like that. And then so that's just one word, and then you go to the word data and you can have the same conversation. So one of the things is trying to find, and one of the reasons we like and talk about systems thinking so much, is it seems to be a place that's common, even if you haven't used it as a quote, a hard scientist or more mathematically inclined. You probably have, you just haven't called it systems thinking, right? And so it's a place that where everyone can step back and go, oh, okay, so we have this system filled with objects, including people and institutions and technologies, and they have all these relationships to each other, and we're trying to understand the ebbs and flows and the dynamics and the interactions between them. And then now you have a common way of going, well, we can all agree on that. And then now we can go, well, are we going to use math? Are we going to use qualitative stuff? Or are we going to use a combination? But that's then because you need some common place because they are so different in how they think about and express what understanding means. And one of the things Jennifer and I've talked about a lot, we use a little cartoon, can't remember where we stole it from, is just how in the physical sciences, when you start off at, atoms and time and distance, you can be so specific about stuff. And then as you move up and you go from, into chemistry, still pretty specific, biology, still pretty specific, but you're starting to, genotype is a lot more specific than phenotype, right? And then as soon as you're into, psychology and sociology and anthropology, forget it. Like you're just into all these emergent notions like happiness and love and cultural dependence that are really hard to quantify. And one of the things that, and that's where we think you really need to bring in the two disciplines, right? If you're really just talking about a bunch of molecules bouncing around in a box, they don't have personalities, right? They're all just going to obey the second law of thermodynamics, and that's that. But that's not true. You have a bunch of people bouncing around in a room, they're going to be behaving very differently. So I don't know. I'd wandered off. I knew I'd wander off at some point. I forget quick, somebody jump in. And
Yeah. Gotcha, Scott.
Systems thinking, yes, that's what I wanted to bring up.
And just to systems thinking, so just to tie it back, in terms of the language, so that's part of why I was talking about just the notion of models, and that within UX we are using models. It's just we don't think of them as models. And just so what is Scott talked about, any words, right? We all can use them and mean different things, but it's just part of building that bridge is just understanding we're all modeling. We're just modeling in different ways. You might be modeling with numbers. I'm modeling with a narrative to describe, this person's goals and what they're trying to achieve. Absolutely, you could probably describe the exact same behavior with a table of data. It's just the cognitive load is different in terms of if I tell a story using a persona or you give me, a raft of data to figure it out, right? It's different representations.
So one of the things, so on the math side, one of the things you're trying to get to actually call it a model is, something with a bunch of equal signs, right? You're trying to get a bunch of equations. Even in machine learning, you just have tons of parameters, right? But eventually the model is, what are all the weights on my parameters? I go back and forth through forward and back propagation. I use calculus and I kind of settled things down until they're optimized, which means I can assign numbers to all my parameters in my math model. But in the end, it's just a whole bunch of equations, right? And equations are just, hey, this thing over here is related to that thing over there. And in UX, we're doing the same thing. This is related to that. People, carrying on luggage is related to how precious they think the luggage is. That's a relationship. So is E equals MC squared, right? It's just it's a number relationship, right? And so, and then trying to figure out what the tie-in between them is, right? So if you have some sort of empirical data, and most of the time when we do data science across something like how's an airport behaving, it's some empirical model that's searching for, it's not E equals MC squared. E equals MC squared was deduced by a very smart person saying this is how energy and mass are related. But when we're trying to deduce how luggage is related to gender or something like that, we're not actually trying to deduce it. We just notice it, right? And then we're trying to get at true insights through the psychology and anthropology and sociology aspects of things. So those relationships, so we get those relationships, and then maybe we can put numbers around them too, right? Which adds a whole other power to them. If you can start to say 30% of the people who are doing this will do that, but we need the why behind it.
I like how you went from, at the genetic level or, purely in the physics side, the rules apply and they're not changing. And then as we're going towards disciplines involving people, behavior is constantly changing and people are not that easy to predict all the time. That taking that a step further is also acknowledging how things change over time. And Amir, I know you have experience with active learning and feedback loop mechanisms. And that's kind of where I think it's a powerful example of where UX and machine learning need to come together to account for these changes over time. And how do you incentivize the user to even take the time to tell you, you failed here? Because if that's not in place, I'll let you speak a bit to it, but then I have an example after of how it can miserably fail.
Yeah, definitely. I have worked with a few different product teams, and one of the important design questions for us always is how to collect user feedback. And one of my important principles is that the user feedback cannot be upvote and downvote. Because if the label we are collecting is not part of their workflow, first of all, they're not going to do it. Second of all, it's not going to be any signal of significance. Essentially, you might like something and just upvote it, but it doesn't mean that it's relevant to the actions that you're taking after that. So that design around how to integrate this machine learning predictions into a workflow that the user has to do actions, has to take actions, and then how to interpret those as labels to retrain your model, especially in active learning paradigms. And for those who are not familiar, those are scenarios where if the machine is not certain about a prediction, especially in the cases where the labels are very scarce, the machine would present that to the user and the user provides a label for it. And then the machine uses that to improve future predictions. But, a very important design question there is, how do you ensure that, first of all, the introduction of these uncertainties into the user workflow doesn't interrupt them? But also, whatever you're interpreting as signal, as their feedback, is actually meaningful. It means what you think it does. Back to you, Roxana.
Yeah, actually, so the whole idea of the uncertainty. So we've worked on a project with live surgeries, and there was a tool, AI-based, predicting things or giving recommendations of this is where you cut, this is where your next move goes, and with really accurate, like well-placed cameras, and I'll spare you the gory details, but some of those predictions for the cutting, for example, was incredibly accurate. But other ones, let's say where you may need to understand the softness, the tenderness of the membrane, I guess, it was not quite the same. So basically, the algorithm had perfect predictions for some things and really bad precision for others, but it was missing that component of saying, I know I rock at this and I know I suck at this. So then as a surgeon experiencing it, it's like, well, I'm looking at something and it goes against everything they knew, then they stopped using it because there was no trust and there was nothing on the design part to say, this is trustworthy, this is not. That component was completely missing. So something that could have had a really good and a positive outcome for both the surgeon and the patient, if used properly, failed as a tool until those design mechanisms were put in place to distinguish between this is a good prediction versus here, I need your feedback. I don't know what I'm doing yet for whatever reason, lack of data, whatever it may be.
Yeah, in a lot of ways, trust and control kind of go hand in hand in a lot of situations. And we don't have any kind of standardized affordances in interface to indicate to somebody, like, on my laptop, right? The light's on, my camera, because I know that we're recording. There's a red light on, so I know that it's recording something. How can we indicate to people that it is still learning, or that, or that the prediction is pretty certain in this area? This area, I'm just being as smart as a puppy right now. I'm just going to show you something and hope that you'll be, think I'm cute and tell me, if I'm doing good or if I've made a mistake, and, let me learn some more about it. How can we, express that to people so that we're giving them that sense of control, but also maintaining their trust by acknowledging, we're kind of informed, but we're really guessing right now, and looking at you to help us, give us guidance so that we can learn more and better tailor the predictions that we're giving to better meet you and your needs.
Yeah, I think there's a lot of how you want AI and just tools to behave in general that you can often answer just by thinking, how would you want a person to behave in the same situation? If you had someone saying beside you going, hey, I've been doing this for 50 years, man, this is where you cut, like right exactly there. This is all I do for my life. How about this? Well, I don't know, right? Then you trust them, right? Because you trust people who tell you they don't know what they're doing too, right? When they differentiate between what they know and what they don't know. And I think that a weird sort of thing there's almost a cultural thing in products that you don't want to admit you're not really good at something, right? But if you're trying to establish a relationship, which you are, right? Because you're giving directions, you're sharing information, you're working on something as a team, even though part of that team's a a robot, AI, an algorithm, whatever. You have to act like how a person would act in that situation, right? And that's that's part of the whole, a lot of all the angst around machines and AI and things like that, or this, thinking about what are our relationships with them, right? We get the paranoia, like, will they take our jobs or take over the world or stuff? But just on the more mundane stuff, it's just this, yeah. How do we work together? How do we trust them? How do we understand how those scenarios work?
Yeah, like Jennifer was saying, and both of you were saying, right? Like part of it is this trust part, and the other part is the control part. And I wish Serena was here because she loves recommender systems. But the first example that came to mind was just that, recommender systems, right? Like I've seen it even with, like, I've watched too many Christmas shows during Christmas, and for some reason, apparently Netflix thinks I should be watching them all year round now. But jokes aside, like, how can users access things beyond the recommendations linked to their initial profile, to kind of influence those recommendations, or say that you actually got it wrong here? Yeah. And in many applications, that's completely missing. I recently used an app for habit formation just to try to get a bit healthier since we're all home 24/7. And I had to download and reinstall the app 3 times because it was doing recommendations of journeys based on my initial profile. And there were things that, whether it's because of COVID or because of my personal circumstances at the time, they were just not appropriate or doable for me. And I had no way to change that without going back, downloading the app again, and lying about some of the factors that I thought may have led to that recommendation. And that's, of course, like, you're not going to do that too many times.
So that's interesting. The whole, one, and I think I agree with this point of view, is we're still not at the point where, machine learning has like common sense, or what we call common sense, right? So so something like the Christmas show example, right? A human wouldn't make that mistake because we think of that as common sense. But we know machines, their whole world is whatever we've programmed into them, whatever data we fed them, right? So I love it's probably an old example now though, but of the, first automated cars stopping to wait for the snowman to cross the road, right? And then eventually got to go back and teach it this snowman, and you don't teach it about snow, right? That's the thing, right? You teach it about snowmen in this situation, and right? And so one of the things, the Christmas thing makes me think of is you need that feedback loop built in. I mean, the programmer is not going to catch every possible scenario. So how do you get it so I can use my common sense, pass to you, the machine, my common sense, and say, look, you should know, by the way, right? Whatever it means for them to get it, that Christmas shows all year round just doesn't make sense, right? It was a pattern that made sense over these 2 weeks for me, right? It's a complex problem, right? I mean, it's easy to state, but hard for the poor people writing the algorithms to know what to ignore, how to express that. How do you capture common sense so now the machine can do something with it, right?
Yeah, and I think it goes back to our Cynefin framework again, right? Where we need the user experience researchers working with the data science to bring a more wholesome view to people and their behavior and their patterns. And I think, so there, Roxana just talked about time in terms of like seasonal needs and how things change, but also we've talked about just how your relationship with an application changes over time as well. Roxana, you talked about having to reinstall the app to kind of reset it, but that transparency is missing to give you the sense of control. It's like, okay, I'm in a different place now, or I want to focus on something different. How does the application make it evident to me that I can influence it, right? Like that I can retrain it in a way, and how is it giving me an affordance to let me know that I'm in the process of retraining it so that I don't have to go through just deleting the whole thing and starting from scratch again? How can we kind of open the black box a little bit so that people can have that sense of control as things are changing over time and as their needs are changing in terms of what they want to get back from the service or application that they're using?
That's interesting. The whole and starting from scratch might be the worst thing, right? What you want them to do is learn over a period of months. The advice you gave me 3 months ago was great, but now it's patronizing, right? Because I know all that stuff or something. There was the conference, one of the conferences, I think it was Roxana and I gave the talk, but maybe Jennifer, it was you and I. There was a woman who talked about there's explainable algorithms, and then there was another word she used for algorithms that and it wasn't so in explainable algorithms, you kind of take something like a machine learning algorithm and then you reduce it to a pattern of kind of going, hey, this is sort of what's happening, but it's not precisely what's happening. But she was advocating actually, look, sometimes you can do more complex algorithms and make them explainable. So it's actually more complex math, which is weird, but the math is more explainable. Just like you can explain general relativity to people, even though it's second order nonlinear differential equations, which are most people won't get that, but it has a bunch of words you can turn that into, right? And you can say matter spends space and time makes matter move. And oh, I get that. And so the theory can be complex. And her whole point was, oh, the theory can be complex, but what's inside the black box, I can give you an explanation for. And that was something where I go like, and it's worth doing. Look into, is there harder math that's more understandable that you can give a model to? Because one of the problems with the kind of classic neural network is, so how does it know it's a cat or it's a number seven or something? It's like, okay, we have no idea. There's a pattern there, it's figuring out, but you can't match that to a pattern that we can think about, right? And in fact, most of the videos on that say, wouldn't it be neat if it said it was like it was figuring out this curve, and so since it's a curve, it's a 6 or a 0, but that's not what it's doing. Here's the pattern it's figuring out. We're like, what the hell is that pattern? Like, I don't know. Well, that's because there's like a gazillion different weights. I think there's something, and I feel like that's something we could push for the UX community. Say, look, is there math you can do that's I can't remember what she called it. Let's say super explainable or something. But she had a word for it, and she had a whole bunch of examples where they'd done this. Pretty sure she was at Columbia. And it was super interesting though that, hey, my algorithm isn't just a black box that you can't understand. the math is really hard, but I can explain it to you. And then people would trust it more, right? Because they have a, they have a story around it that is, oh, it works like that. I don't know how to do second order nonlinear differential equations, but that story you told me makes total sense.
Kyle in the chat is saying that there's a lot of transparency problems with the current products, as you mentioned a few examples, and he's saying that if companies were quite transparent about what data they're collecting to make those recommendations, probably people will be scared and won't use their product, which is fair. But I think one thing that was very interesting as I was listening to the conversation for me was that, coming from a data science and machine learning background, I always think about explainability and trustworthy AI from the viewpoint of the backend, pretty much. Like, what can I do to these models? As Scott was saying, can I create post hoc explanations to explain my black box model? Or can I use models that are interpretable either locally or globally? And by the way, we have a package on that whole topic of explainability that I will include in the show notes. So that's definitely very interesting. I think there's a lot of conversation about it. But what was interesting that I heard from what Jennifer said earlier was that trustworthiness is not only what can you layer on your back end to make explanations and responsible use of data possible, but also how would you design the user experience in a way that trustworthiness come across? Like you could potentially provide explanations, but if the user doesn't conceive them and perceive them as explanations that are convincing, then that's not a very helpful explanation. Like you've done a check mark, but from a user experience point of view, it has not achieved what you were trying to do. I want to go a little off script at this point, if that's okay, but I'm very, very curious to hear your thoughts on the following. I've been reading this book called Book of Why. I don't know if you've read it, but it is a book about essentially counterfactual and causal reasoning. And a lot of the problems that we are talking about around the problem with data, that we can only observe partial signals from it, and the context is missing, like the lineage and assumptions about the data that was collected and what can be inferred from it. Essentially, the book argues that that's a fundamental problem with the statistical methods in general, including machine learning methods, because they are not causal methods. Like a lot of them lack the important component of counterfactual reasoning. Like you can see the correlation that exists in data and draw conclusions about the correlation, but none of that, well, we all have heard, correlation is not causation and such. But that's a very significant problem in machine learning, because the models that we use largely are not counterfactual, largely are not causal. So all you can see is patterns which reflect correlation. So I know it's a little off script, but I'm very curious to hear your thoughts on that. Like and the book, talks about the frameworks that are necessary to be layered on top of the common statistics to include that kind of reasoning. Because as Scott was saying, in physics, the reason that we can make generalizable conclusions is that we can explain things with simple formula. But those are causal formula, like what is the cause and what is the effect in a lot of cases. But in machine learning, that kind of thing doesn't happen. And a lot of the time we are making generalizations that are not within the realm of what the data can support. A lot of context is missing. So I'm curious to hear your thoughts on that. Like, is that something you've thought about? I'm sure you have, but what are some of the ways to deal with that?
So one of the ways. Sorry, someone else want to go? So one of the ways is there's a practical thing that you said essentially, which is one, don't start off by assuming you can extrapolate way beyond what you can, right? So a good example from physics is when Kepler, I don't know if you guys remember, Kepler figured out that the planets went around in ellipses, basically. But he didn't do this wide extrapolation to, oh, that tells me about everything else. He just said, if another planet shows up, I bet it goes around an ellipse, right? And then when you had something that was a deeper observation understanding like Newton, and he said, hey, the way gravity works, there's a reason things are going around ellipses, the reason apples are falling, they're all the same thing. And so I'm going to extrapolate like crazy because, and that's why, it's laws. He's got 3 laws, right? But often we just tell ourselves stories, I think, that's where we've, the whole gender example, if you're going to quote explain that, then you just have to make up a story that somehow from what? I mean, just out of your head, right? So I think, whereas if you have existing other complementary data and or existing models that have been proven to be true in other cases, people behave this way or something, and then you apply them, and then you apply the multiple perspectives and models, that's where I think you start to get into, okay, so now we can start to be confident of understanding. Because it's really not like statistics describes, it's a weird thing too, right? The way statistics works is almost backwards from, so if I start at quote math and I take something like the central limit theorem, I go, if a population has these characteristics, MIID, blah, 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 I apply the central limit theorem, I'll get a bell curve and, confidence intervals and all this stuff. And that's going from, if a population, I end up here, right? But what you do with statistics is you go back the other way, right? You go, hey, I made all these observations, I see a bell curve, and so I'm going to go back the other way and make a bunch of conclusions. And someone said earlier, so even just on the simple math stuff, you better make sure those were independent, right? Because if you're going back and you didn't check or know your assumptions, you're screwed. Now, imagine that complexity, like orders of magnitude more complex. Oh, I saw, women put this type of luggage on way more. Now I'm going to go back to what? Right? Like, because you're reverse engineering with statistics, because they are just observations of behaviors of numbers in some system and measurements that you've got. And if you don't have some sort of theory underpinning it, you're just, in a way, just making it up almost by definition. Right? And so you need all these other ways of going, well, I understand the system this way, I understand it that way, I've seen people behave this way, when I talked to someone, I saw this, I have this other observation. Now, collectively, that seems to be consistent with, statistics. I have a friend of mine who often he uses the example of, when it gets hot, ice cream sales go up, right? So the heat's causing the ice cream sales to go up. But he goes, if you're using statistics, how do you know it's not the other way around, right? So you're very limited with statistics if you don't have some other models or sets of models to kind of say why that's going on. So I'd be curious what the book said. Well, no wonder it's called Why, or Start with Why, or Here's Why, or whatever it was. So
Just
go
to
ahead,
add to
Jennifer.
that, Scott, that one example that you've used before was just with that the data set that you had, and it was when you went through it, it showed that if somebody had received a text reminding them about that they had an upcoming appointment, they were less likely to show up for the appointment. And so that's when that common sense kicks in. It's like, I'm sure that's what the data says, but clearly there's something else going on. So, hey, user experience researcher, I think we should go out and do some interviews to understand what's actually happening. Is that text going to a caregiver, or is the text going to the person, but they need the caregiver to get them appointment? Like clearly there's something else in the ecosystem that's having an influence on it that just isn't being included in the information that we're looking at.
And don't tell yourself stories. This example is actually on Kaggle. It was like one of those data sets that you just download and look at. And people were in there with all sorts of just telling stories about it. But, oh, that's because, people just don't pay attention to text. Well, we have no idea. Everyone had a story, though. Right? So the only fact we had was, and to your earlier point, Amir, don't even know how good the data was. Right? Was it really randomly sampled? We don't know. Right? So, yeah, you have to work hard. Statistics don't tell you cause. Right?
So if I were to summarize all that just in my head, it's like, well, you find the pattern. First, you go ahead and see if that pattern is actually real or it's an artifact of the data that you have happened to collect. Step one. Step two, if it's real, dive in deeper with a bunch of whys, not just one, to figure out what's the motivation or reason behind it. And that can actually feed into causation. Right? It's as simple as that. And I think the trick is, if the pattern seems too much like common sense, like the technology and age one, in some cases, we can't just base it off of that. We still need to go through both steps, right? Because otherwise we'll feed into stereotypes for the wrong reasons. Not that there's a good reason.
That's a good reason
so,
for stereotypes.
This is very sad, but unfortunately we have to wrap up this session. This is a very good conversation. We can probably continue talking for hours. I learned a lot from all of you. Thank you so much for coming on the show today. And hopefully our audience has learned a lot about it too. I can see they're writing a lot of things in the chat, so that's good. At least some of what you're saying is resonating. But, you know, we have 4 minutes left. Maybe each of you can take about a minute to just, you know, do a wrap up of everything that you think, like last thoughts that you want to share, and make a call to action. What do you want people to do with this information? Roxana, do you want to start?
Let's go first.
Okay, well, I guess if you're listening to this and you're coming at things from kind of the UX perspective, like down, as Scott was talking about, down the kind of across the spectrum of disciplines from math to more human focused, reach out to the mathy people on the other side of things, have a conversation. And similarly, if you're on more like the math data science side of things, reach out to the social science, cognitive science, UX researchers in your work environment, in your place, to just, because it's just by bridging these disciplines and bringing them together, it's just going to bring much, much better solutions that bring more value to the people that are actually using them.
Yeah, I think that's I echo that advice. Reach out. Another thing, because that's what's needed. People are going to solve things that we wouldn't think of in a million years. Another thing is look for that common ground. We think thinking about models and systems and things like that is because you need to work together. You need some sort of common ground, right? And every time, you know, reading books, there's a whole ton of books like Thinking in Systems, the Signal versus Noise book, the new Daniel Kaufman book, like that people on both kind of discipline sides can read. I bet that Why book's another good cross-discipline book, right? There, you know, you don't have to read a book on, you know, advanced statistics if you're in UX to try and talk to data scientists. You can read something like this book called Calling Bullshit, which is interesting of things that go wrong and weapons of math destruction. They're easy to read, a little negative. Read a positive book too, like Signal to Noise. But learning about, and then, you know, on the flip side, if you're in data science, learning a bit of the UX stuff, just so you get a feel for it, and then finding that common ground because you'll figure out stuff together.
Scott and Jennifer stole my call to action, so I'll come up with a different one, a bit more selfish one. If you happen to work at the bridge of these two fields, or you find yourself in the midst of a project that kind of taps into both, reach out to Amir and I, and we'd love to have you as a guest to kind of tackle this bridge together.
So much for wrapping up your thoughts. I've been a big promoter of product lens when we think about using machine learning. And I think a very significant part of the reason that I'm excited about the topic and I promote it and advocate it is that everything that we talked about today, like ultimately we are using machine learning not for science fair projects, but for projects that are affecting people's lives. In some cases, we might build things that just exclude people. And in some cases, we might build things that hurt them. And making sure people are at the table when the design happens and then throughout all the stages of development and distribution, to make sure that all voices exist and all parts of the population that can be affected by these products are heard and their points of views are included, is very, very important to avoid exclusion and hurting people. So hopefully this conversation was sufficiently random for you and at the same time sufficiently educational. Thank you so much for listening to us, and hope to see you next week when we are going to talk about AlphaCode, the algorithm designed by DeepMind that writes code apparently almost as good as humans do. All right, see you all next week. Thank you for joining us.
Thanks, Amir.